Hello, my name is Mustafa Gurbuz. I'm in section W19 for the Constant Velocity Lab in Physics 2211. Here's a quick overview and a table of contents of what I will be covering inside of this slideshow. So for the introduction, the purpose of this lab is to help understand Newton's laws by analyzing the predicted and observed motion of an object moving at a constant velocity. By doing this in an app called Tracker, it also helps us develop our coding abilities, and by making a video, our public speaking skills are furthered. Some fundamental principles we use in this lab are Newton's first and second laws. Newton's first law states that an object in motion will stay in motion and the same velocity unless acted on by an external force, and an object at rest will stay at rest unless acted on by an external force. Basically, F net equals zero. Newton's second law states that the acceleration of an object is directly proportional to the force acted upon it and inversely proportional to its mass, commonly known as F equals ma. So some previews of our main result is that the observed position was less than that of the predicted position. This can be seen in the right-hand side graphs. Assumptions, models, and initial sources of error. For our assumptions, I assumed that there was no external forces applied on the object and the object has a constant mass. This would satisfy Newton's laws. Models, we used a position in meters versus a time in second graph. For initial conditions, my initial condition was that object starts at the origin of the position. My system was a cylinder. My surroundings were the table and the hand releasing the object, so my hand. Some possible sources of error in this lab are friction and air resistance, causing the velocity object to decrease, leading to a deviation from the predicted outcome where velocity is constant and F net is equal to zero. So friction and air resistance could have made it so that Newton's first law does not hold up. Secondly, because I manually entered the point of mass for the object I'm using in Tracker, it is possible that I clicked too far or too close to the one beforehand, causing the velocity to vary more than normal. And lastly, rounding errors and using less decimal places for the slope calculations from the Tracker data could lead to some errors in getting the predicted results. In getting my experiment data, I first rolled the cylinder on a flat table and started recording when my hand was not in the frame. This was so that if Tracker's auto tracking feature worked, my hand wouldn't cause any disruptions and it could safely track the cylinder. I recorded from bird's eye view so that the change in position of the object would be seen the best. I recorded the length traveled for the cylinder as well as the duration of the video and calculated the slope of the data using the x in meters and time in seconds data points seen on the left side photo on the bottom right. I then took these points and changed the original code with the different time direction and different velocity. I'll talk about that next slide. And then I lastly compared the two models. So here's how I changed the code. I changed the time to be less than 3.3 seconds because that's the time duration my video was. I changed delta t to 1 over 30 because that was the FPS of my video. I sent fnet to vector 0, 0, 0 because velocity was constant and there was no acceleration, therefore fnet was 0. And that this also holds up Newton's first law. I didn't change velocity because the object should have constant velocity, but I did change the position vector's x coordinate, and I calculated that from the tracker data. Similarities and differences between the data. The predicted graph keeps moving in a constant velocity, having a constant change in position over time. This upholds Newton's first law, where an object in motion stays at motion at the same velocity. However, if we look at our observed data, the velocity decreases as time increases. This would imply that F net is not equal to zero, because if it was, Newton's first principle says that it should keep going in a constant velocity. And you can see the observed position is the blue line, and the predicted position is the orange line in the bottom right graph. However, if you look at the beginning of both graphs, it shows that they are going at the same rate of change of position because they're in the same line, meaning that it actually satisfied Newton's first law until an external force acted on the object. So what if slash what does it mean? If the x and minus x axes were interchanged, then instead of the position increasing in the x direction as time increases, the position will decrease in the negative x direction, still leading to a constant velocity, just in the opposite direction. It would also show that the observed model was still less linear than the predicted one. The observed model had decreasing velocity, meaning that the net force was not zero in this experiment and that other factors slowed the object down. Thank you for listening.